Hello, I'm Alex Steven. I'm an engineer working on the API Enhancement Proposal, or APE project. Today, I'll be demoing a Terraform provider that can be generated with no additional effort on top of an APE-compliant API. The thesis of the APE project is that a consistent API design can not only lead to more user-friendly APIs, but also allow us to build user-friendly tooling on top of those APIs with minimal or no effort. To learn more about the APE project, the other tools that we're developing, and the specification itself, you can visit aep.dev or go to our YouTube channel, youtube.com/aep.dev. To demonstrate how the APE Terraform generation works, I'll be cloning a Roblox data store today. Roblox APIs are not officially APE compliant, but they happen to follow almost all of the standards that we need. Quick primer on Terraform. It's a tool that allows users to declaratively state how they want their configuration in the cloud to appear. Terraform is one of the more complex tools in this new category of infrastructure as code, so we can use it as an example to see how APE-compliant APIs can be easily integrated into other tools like Kubernetes, Pulumi, Ansible, and a variety of others. Now, what is Terraform actually doing under the hood? Terraform's superpower is figuring out which API requests need to be chained together in order to achieve the user's intent. Traditionally, you'll see an entire team of people that are staffed up to build a Terraform provider, where they have to make the provider understand exactly which APIs need to be called, how to call those APIs, how to parse the API responses, and then how to figure out which actions need to be taken based on the API response, all in order to get the user's intent across. But by following APE constraints when designing your APIs, these are all a variety of solved problems that can be solved without having to staff an entire team. So let's go ahead and jump into our demo now. I'm here in my IDE and terminal with a Terraform script that I wrote up a little bit a while ago in order to create a Roblox data store. This script includes such things as some headers, including my Roblox API key, and then the actual resource blocks where I create 10 different data store entries with various IDs and values located here. This script calls the ape Terraform provider, and the provider is responsible for actually making the API calls. So let's go ahead and clone these 10 data store entries. So I'm going to create a new block here, and we're going to add these to a new data store. And while I'm at it, let me change a couple of these values, which should reflect both in my newly cloned data store, but also my original data store. That looks perfect. Let's go ahead and run Terraform. Now, Terraform is going to compare the state of the Roblox cloud against what I just wrote up. So this requires Terraform to not only programmatically send a whole bunch of GET requests, but understand the responses of those GET requests so that it can diff against everything that I've written up. So it looks like we'll be creating 10 new data store entries, but then also changing those 3 original data store entries. Nothing else will be altered. Sounds right? So let's go ahead and run it. In the background, Terraform is figuring out exactly what API requests need to be sent, so it's going to send 10 different post create requests, it's going to send 3 different patch requests, and then it's going to send a bunch of get requests at the end, so that once all of these changes have been made, it can absolutely make sure that the state of the cloud matches the state of my configuration file. So it looks like all of that has been done, and now we've successfully cloned our Roblox data store in just a few lines of Terraform configuration. Thanks a lot for watching this demo. Hope you enjoyed it.